Good evening, everyone. I'm Tasnam Gill, and I am presenting on behalf of Team TASAS. Our project is automated attendance using facial recognition, and this project is a part of midterm examination for the course ICT428, Computer Vision and Augmented Reality. This project has been developed using Unity, OpenCV for Unity, and HAR Cascade frontal face pre-trained model. There are many real-world applications for this project, such as workplace and office security, conference and events, healthcare and hospitals, and for law enforcement and public safety. However, our primary objective for this project is for automated student attendance to reduce manual roll calls and to prevent proxy attendance, which means students marking attendance for absent friends. Each member will be presenting about their contribution to this project. Starting off with project background and concept. This project is a real-time face recognition-based attendance system implemented in Unity using OpenCV for Unity. This idea is to automate attendance tracking by recognizing faces captured via the webcam. Instead of manually checking names, the system detects faces, compare them with stored images, and marks attendance automatically. The key goals are to use computer vision to detect and recognize face. Second is to maintain a database for registered faces and to compare detected face with stored images using image similarity matrix. And the last goal is to log attendance data in CSV file for record keeping. Moving on to the next slide. Face detection and recognition. This project uses HAR Cascade classifier, a pre-trained face detection model to detect faces in webcam frames. And here is how our system works. The webcam first captures a frame and converts it to grayscale for better detection. The HAR Cascade detects face in the frame and returns their location, and the detected face is compared with stored images to identify the person. If a match is found, the system logs the attendance. And before I start off with the function breakdown, we'll first like to show the demonstration of our project. Using facial recognition facilitated by OpenCV for Unity. Initially, we need to record our data in the database if we have not already done that. So this is the database, and currently my data is not saved in the database. And to do so, we need to first enter our name and our student ID. If we try to save the data without first entering the name and ID, it gives us a prompt telling us to do so, as you can see on the screen. And I will go ahead and save my data, and I'll go ahead and type my name and student ID. And then I will capture the photo to save my data in the database. And as you can see in the database, my data has been saved. And after doing so, I can check the attendance using facial recognition. And from the feedback, you can see, and from the feedback and from the live attendance, you can see that I have checked the attendance. It shows my name, my ID, and the time at which I have checked it. And we will now be talking about function breakdowns. And In this part of the presentation, our members will be talking about the functions that they have contributed to this project. Starting off with the function that I have contributed, it is in the start. The the start function initializes the system, opens the webcam using OpenCV's video capture. It sets the resolution and initializes required matrix for image processing. It loads the hard cascade face detector. It sets up file paths for face database and attendance log, and it links UI buttons to their respective functions. And for the update function captures the live webcam feed. It reads the webcam frame and converts it from BGR to RB. Next slide. And this is the check attendance function, which detects the face for face detection and recognition. It converts the webcam frame to grayscale, and it uses hard cascade to detect faces. If a face is found, it compares it with stored face images in the database, and if a match above 80% similarity is found, it retrieves the person's name and ID from the file name. It logs the attendance in the CSV file, and it displays a messages and updates the live attendance list. So as you can see the face database and the attendance log, and you can also see the stored faces in the database, which are our members and their IDs. Moving on to the next one.
So in this project, the function that I mainly wrote is the capture photo. So when a user wants to take a photo for attendance, the system first check that the both name and ID fields are filled. And this is important because the system names are stored image using the username and ID. And if either field is empty, and the system asks the user to enter the missing information before continuing. And once the user provide the relay input, the system capture an image from the webcam. And before saving the image, is check if the face is present. And the system first convert the image to black and white to improve the face detections. And then is use the face detection tool called the cascade classifier to find face. And if no face is found, the system inform the user and does not save the image. And this one is about the save the detect face as an image. And if the face is successfully detected, the system proceeds to store the image. And first is create a new texture from the current webcam frame and extract pixel data from it. And this texture is encoded as an PNG image and saved in a specific folder on the device. And the image is stored under the structure file name format that include the username and ID.
So for my part, let's begin with the before stage of our AR/VR system. At this point, it's a clean system state. No student data has been added yet. That means no names, no IDs, no capture photos, and no attendance records are stored. The system has the capability to see faces through its face recognition framework, but it doesn't know who anyone is yet, and is ready to take in information like a blank canvas waiting for the details that will make it recognize students in the next step. So now let's fast forward to after part. Next slide, please. So once we feed the AR/VR system with the data, names, IDs, capture photos, and attendance history, it transforms. The system learns each student's face and their details. So once a student step up, show his or her face, the instant recognition will occur. Their names, IDs, and facts pop up, and the attendance is marked. All are in real time, and besides, no more manual lists or wasted times will be appear. It's fast, accurate, and scales effortlessly. Whether you've got 10 students or 100 students, This is where efficiency meet innovations, making life easier for educators and students. This is all for my part.
Hello, Ajahn. For my part, I want to talk about the show feedback method. This method is a part of the system for improving user experience by providing informative and immediate feedback to the user during interaction. The reason to use this method is to inform the user real time about key events such as the camera has been closed or the attendant or the student has been recorded. For example, when the camera cannot detect the face of the student, the system will display the message, and which is the face cannot be detected. This method takes two parameters. The first is the string message, and the second is the duration. And in this case, the duration will be 3 seconds, but it can be customized. And after that, we need to check the feedback text object is assigned or not, because we can run into the error if it does not exist. So after that, we deliver the data or the message into the feedback tag object, and then the feedback tag message will be displayed in the segment. And so afterward, we have to use a cancel invoke method function for high feedback method in order to prevent any previous hiding action. And then we schedule the high feedback method, and which will delete the message after displaying for specific duration. So this kind of automated removal of the message hand to maintain a clear user interface, and then it ensures that user only see informative information about the key event without getting distracted. Next slide, please.
So, and in my talk, I'm going to discuss about how our system log attendance use face recognition technology and why it is essential for accurate record keeping. So, the purpose of attendance logging, the main goal of our attendance logging system is to automatically record when a user is recognized by the face detection module, and this eliminates the need for the manual sign-in and ensure the efficient and accurate tracking process. And each entry includes three things. The first one is user name, the student name or employee name, and their ID, and employee ID or maybe student ID. So, and the last thing in time stamp indicating the exact time and date of the recognition. So moving on to the next slide, please. System work. So first of all, when a face detect, our system component is we store image, and it may found with more than 80% confident the system log the user information, and appended is to attendance log, and this ensure only verified individual are recorded. And so, and also, we also need to know what the attendance data is stored. The attendance data are stored in the CSV file format and located securely on the device. This format allows for easy exporting and processing and integration with other attendance management system. When not for the reporting, analyze, and data remain accessible and well organized. So for the conclusion, our automated face organizing system enhance efficiency, accuracy, and accessibility. So by logging tenants in structured formats, it simplifies tracking, reporting in our system. Thank you so much.